really small, taking it back to our middle school days. Think about 15 times 3, 13. Okay? So I'm just going to draw an expression or a picture. What's the relationship between that picture and the actual expression? What do you see? Talk to your elbow partner, although just one elbow here. What are you seeing here? How was I able to do that? 2, are they the same? And if they are, what's the relationship? Okay, so what I'm hearing, as I was eavesdropping, I heard that for the top, I have 10 and 5, 10 plus 5, 15. And then on the side, I have 10 and 3, 10 plus 3 is 13. Think about the size of each, right? I'm saying this is a 10. How long is this side?
Well, that's 10.
10, right? So a 10 by 10. And think about the words by. Then I have a 5 here, but I have a 10, so that's a 5 by. And then down here I have a 5 and 3, so 5 by 3. So when we keep saying 5 by, 10 by, what's that operation? Multiplication. So in this first square, I have 10 by 10, which is, what will go here? And then finally, put this on your A. Just so you can see what that looks like, I want you to have that as a tangible piece, so that when you look back at this later, you're able to understand the coherence that we're trying to move to. So in middle school, Eureka focuses on units. It's called the story of units for 6 through 8. And so there, everything is depicted in base 10. When you get to 9 through 12, it becomes a story of functions. And that's kind of where we're going to head to today, is hitting on the story of functions, but building from here. Now, my goal is to find 15 times 13, but what am I going to do with this mess in the middle? Right, add them all together, so I'm going to draw my arrows. That comes down to 100. Diagonal. Diagonal. So then I end up with 100 plus 80 plus 15, which means, what is 15 times 13? Right, which is 195. So in middle school, they use a rectangular array. That's what this is. This depiction is a rectangular array. Some kids might call it the box method, whichever way you want to call it. But in middle school, it's called the rectangular array.
Rectangular array.
Mm-hmm. And we're able to call it a rectangular array because, as Ruben said, this was 10 units of some sort, and then this was 10, so I had a 10 by 10. Each box represents the area of that box. Okay? As always in math, we go to the next level. When they get to 9th grade in Algebra 1, we move away from base 10 into the elusive base X. And for some reason, this really messes up a kid's brain. But what I want us to do is to look at this the exact same way and then set up a model that represents the same one. And as you're setting up that model, I want you to think about language and vocabulary. Because before we could say rectangular array, but we might have to tweak our language to keep going. Okay, so Perkins has, good, both of y'all have the same thing. We have an X here and a 5, X here and a 3. Now, the beauty of this is that by the time they get to Algebra 1, they've already had experience dealing with rectangular arrays. And so for them, the variables x and x are representing just some random number, right? And so this is where properties of exponents will come into play, which they're going to learn at the end, tail end of 8th grade. So same thing. Here I have x, here I have x, so what should go in that box?
X squared.
X squared. Go ahead and fill out the rest. And then as we get the rest of that filled out, just talk with each other and see if it makes any sense, and then try to identify that coherence from story of units into the story of functions.
Products, diagonals, you still get the x squared plus the 8x plus 15. So I get my x squared, 8x, 15. So it'll be x, x squared plus 8x plus 15.
So a question that you might get from here, something that I've seen numerous times, and I just want to talk about it. Ruben brought this up. You said that it's the same thing right here, how we added all those together, right? Why can't I add these together? Right. Right, and so what that makes, that goes into the combining like terms piece. That's a quick little caveat for them to know that I can't add all these together like I could before, because the numbers were all base 10. In this case, since I have base x, I'm not sure what that number even represents, so I can't just combine those unlike terms. What would happen if x was 10?
Well, I can put it because we can go back to my multiplication, 195.
So what's the relationship between this expression and this expression? What do you see? So this expression, our answer, this expression, and our answer.
You said what's the relationship between?
What do you see? What connections could you make between x plus 5, 15, x plus 3, 13, 195, x squared plus 8x plus 15?
The base of 10? Yeah.
Exactly. This is base 10,
Base 10, and that's base
and therefore this is base
10. No, it's base X.
base x. That's the connection.
Mm-hmm.
So allowing students to see that it's the same process, it's just a different base.
Gotcha.
And so in our case, we could say that multiplication works for base x.
Gotcha.
Okay? Now, this is pretty.
Mm-hmm.
Once the students get here, this is like the beginning of Algebra 1, but that continues into Algebra 2. Look at how cute it is in Algebra 2. This is like my favorite thing for Algebra 2. I'm gonna put the same one up, except this time, I don't know what they are. I just know that I end up with x squared, I end up with a 2x, and I end up with a negative 15. I love that negative.
Mm-hmm.
I'm allowed to use negative here because my language has now changed.
Right.
This is now the tabular method.
Right.
And sometimes with my kids, I call it the box method because tabular gets the word tabular, they just take off. So tabular box method, I can no longer call it a rectangular array.
Right.
And so as you two are working together, keep in mind those arrows, they're extremely important. And then let's just struggle. We're trying to factor using the same model.
So we know where our x's are gonna go. already.
And since you know the height is X, the width, the length is X, the width is X, what's the area of that square?
X squared. I think I can put in my X squared in my negative 15.
Perfect.
Those are the two that I know I got.
Exactly. You know for a fact it's gotta be negative 15. And when you get your student and they're thinking the same thing, keep in mind, we know this is negative 15.
Right.
What do I do when I go diagonal?
Adding or subtracting.
Right.
Adding as well,
Right.
because it's a negative.
Right, so here I'm adding diagonal, there's nothing I'm combining this with,
Right.
so it has to be negative 15. And then Perkins said this has to be X, because I know I created X squared.
Right.
You are gonna get some misconception in that first box. That's gonna be a huge misconception. You're gonna have some kids that go, okay, just put it there, which is true. The first term, the first box, for sure. But make sure they understand where that came from. Now what?
Now I got, because since this is a positive 2x, this is a negative 15, I know, if I know my rules, most integers, I know negatives as a positive is a negative. So, that means one of them have to be positive, one have to be negative. However, this is the highest number. Highest
So it
number
has to be
got
positive.
So this one has to be 5x. This one has to be 3x. Oh, yeah.
Say what you just said one more time. Just that language. When you said, if I know my properties of integers, and since this one is bigger, in my answer,
My answer's positive, so that means my largest number has to be positive.
think about when you learn how to factor. Did you ever have a teacher go, well, if it's, can't erase. If you have, I'm gonna try. Okay, so if you have, if you're factoring and you have a minus and then a plus, then it's always something, right? And it's like, oh, if this one's negative and that one's positive, then both of them are negative.
Right.
And then they would say, well, if this one is positive and this one is negative,
Yeah, what is?
right? So these little tricks, that's how we were taught.
Yeah.
But the discussion you just had with yourself makes it stick. Because you know the bigger number is positive, because my answer is positive. When I combine them together, it works. So from here, you said you had, what was up here?
That was 5.
5, and now I give me 5x, and this is negative 3. Does it matter which one goes where? Would it change the problem?
Positive 5.
You mean if you switch places?
Mhm.
Have
If I
the negative 3 up there?
Right, if I put negative 3x up here, and then 5x down there, made that negative
You
3
also,
and that
yeah,
positive.
I think they just change your labels also.
What would that do though?
It wouldn't mess with it.
Why wouldn't it mess with it? What property is that?
That part.
Community.
Community.
We're still in the same community. That's how I asked them. We're still in the same.
I learned it where it's like we're
still in the
moving.
same- Exactly. We
I always
moved
learned
houses, but we're still in the same neighborhood.
Right. So here I can use the commutative property. So now as you look at it, what are my factors for x squared plus 2x minus 15?
X plus 5, X minus 2.
That's it. So from here I know that when I factor x squared plus 2x minus 15, that's the same thing as x plus 5 and then x minus 3. That's a quick, easy segue into factoring. So that could be one quick review lesson. When teachers talk about, I talk about this all the time, about how Eureka is too high up. And so if you're able to provide that lift from middle school and make that connection, because that's the biggest problem. Kids disconnect vocabulary. Because we might have said rectangular array in middle school, and now we're saying tabular method or box method, and they're like, I don't know what you're talking about, I've never done it before. So making those connections are huge. Next step, when you're deep into algebra 2, they would be given these factors
Mhm.
and then just the polynomial. And they would have to find the other factor. That's what division is altogether,
Yeah.
right? If I say 32 and 8, what's the other factor? You will automatically divide. So all of this is pushing that conceptual understanding. And this happens in all of the lessons. All of them build up off of each other. The biggest thing is just understanding what they're doing, so we know that ahead of time.